Okay, it's already recording, so everyone needs to know and accept it.
We should wait a couple of more minutes, or we can start.
I don't know, Brunella, do you want to say?
Yeah, maybe 1 more minute or 2. Yeah, we can wait. In the
sure.
meantime, welcome to all, and happy to see you. It's nice to see each other like once a month for this very nice occasion, you know, of the seminars. So thanks for being here. Yeah, maybe we can wait 1 more minute, and then we are already 40 people, so it's quite an audience. And then Riccardo, whenever you want, you can start. Yeah. Good.
Okay.
Maybe I can introduce you.
Oh, thank you. Okay.
Yeah.
Why not?
So Riccardo, who is our chairman today, he's a PhD student from the University of Bologna. You might know him already because he gave his e-seminar, I think, last time or the months before. I don't exactly recall. But anyway, Riccardo is also part of the committee of young researchers together with Rafa, Victor, Luis, and many others who helped organizing this seminar. So thank you for the work you have been doing. And yeah, so you can start. I think you can start.
Thank you for the introduction, and it's my pleasure to be the chairman of this session of the FruitCREWS seminar. This session is entitled Irrigation Management in Apple and Pear, and warm welcome to our speakers today, which are Dr. Luis Gonzalez Nieto and Dr. Victor Blanco Montoya. Dr. Luis Gonzalez is an applied researcher of fruit crop physiologist in IRTA, Spain, and his expertise relies on applied research on tree fruit production problems. And he is currently working on topics such as crop load and canopy management, fruit quality, in irrigation, and precision agriculture. He has spent the last 3 years as postdoc at Cornell University. The title of his presentation today will be Trunk Water Potential Measured with Microtentiometers for Managing Irrigation in Gala Apple Trees. After his speech, Dr. Victor Blanco Montoya has recently accepted a position as a fruit tree physiologist at IRTA Spain. And previously, he was a postdoc researcher in Lee Kalk's lab at Washington State University. His research is focused on studying water relations in the soil-plant atmosphere continuum and the ecophysiological and agronomical responses of woody crops to changes in the environment and their implication in horticulture. The title of his presentation today would be Physiological Growth and Yield Responses of Pear Trees to Different Irrigation Regimes. So I leave the floor to the first speaker, who I guess is Luis Gonzalez. So please, Luis. the floor is yours.
Okay. Can you see my screen?
Yes.
Okay, I will talk about my work in US with the sensors FruitCREWS to manage water stress in Gala. Let's go. Okay, the objective was understanding the apple fruit growth dynamics and water stress to manage the irrigation to maximize fruit size and crop value in Gala. For this, we did 2 experiments during the season 2021 and 2022 in Geneva, New York. The treatment was rain exclusion. This treatment we never irrigate. This treatment, the second treatment was fully irrigated. This treatment was irrigated by rain and drip irrigation, and the first treatment it's only rain. This was irrigated only for rainfall. For the weather conditions in New York, this is the temperature between May and October during the season, and we can see that we in August is the time that we have the higher temperatures, but the maximum temperature is close to 24 degrees Celsius, and it's a very low temperature in comparison with other areas. This is the rainfall between 2012 and 2022. The average, the all-year rain is the blue area. It's close to 800 millimeters during all year, but during the season, it's the orange area. It's close to 500. We have a lot of raining periods, but in 2016 to 2020 and 2022, we start to have problems with irrigation. Here, the standard treatment of the growers in New York, they don't have drip irrigation. The trees only was irrigated by rain is the standard, but in these years they penalize the fruit size, and for this reason they start to do experiments to manage to manage the irrigation, because before they don't need it, and now they start to have problems. To do these experiments, we adjusted the crop load in all trees and 7 fruits per centimeter square, the transaction area. It's important that all trees have the same crop load, because we want to evaluate what is the effect in the fruit size. And you can see when we have a higher crop load, the fruit size is lower. At the end, it's important to have the same crop load in all treatments. After this, we evaluate strong water potential. It's not the same. It's strong water potential with sensor FruitCREWS and fruit growth with caliper and endometers during all season. And after we evaluate the all yield and quality parameters, the normal quality parameter, the normal yield parameters that we evaluate in apple orchards. Okay, I say before that we have a lot of raining. To do deficit of the irrigation, we installed this greenhouse. This is plastic of the greenhouse. It was very complicated and was a cheaper option. We removed this plastic when we don't have raining, but I say before that we have raining sometimes every 2 days, and at the end, this plastic was in 2021 was during all season. In 2022, we remove it sometimes. This is under to the plastic. Okay, we use the sensors, FruitCREWS. This is the web of the company. In the first seminars, Alan Laxo talked about these sensors. These sensors go inside to the trunk and measure the trunk water potential during all season. This is my sensors. You can see this is my finger. It's a very big hole. I'm sorry, but this is very big. At the end, we have a limitation. We can install these sensors in the year that we can install these sensors when the trees have years old. 5 years old, not before, because the trunk is small and we cannot put. The company are working to do small sensors for installing different crops and small trees, but for now we can use after after 5 years of the trees. Okay, this is the graphic. The precipitations in 2021 in Geneva. We can see that every 2 or 3 days we have rainfall. At the end, we don't need to start the irrigation. We lost one treatment in this case because the trees only was irrigated by rain, because we don't need to turn on the drip irrigation. We have 2 treatments. This is the value, the trunk water potential is the average of 24 hours. And we can see that after every raining period, the trunk water potential go up. At the end, the sensors can detect these variations in the water content in the soil. And we can see that the trees show lower stress when we have raining periods. But when we compare the fully irrigated treatment and the rain exclusion, we can big difference. Okay, but you can see that this on the red line is the trees that was under to the plastic. We can detect all raining periods go in the same way that the fully irrigated trees. But obviously we have stress or more stress in this rain exclusion trend. This is in 2022. It's the same graphic, but here the precipitation was lower. I said before that in 2022 we have periods that we don't have rainfalls. It's here in the beginning of July that the precipitation was lower in the beginning of August. At the end here, yes, we have 3 treatments that I talked in my second slide. After here, we turn on the irrigation is these black lines, all periods that we have deficits of the irrigation. We manage the kernel model to manage this irrigation. Okay, this green line is the fully irrigated trees. Okay, we can see here that we can see the same when we have raining, the value of the trunk water potential go up. But when we compare the fully irrigated trees with trees only irrigated by rain, we can see that these periods that we have more deficit of irrigation, we can see difference between treatments. Okay, in all other periods, the lines go in the same way. And when we compare with the rain exclusion treatments, obviously we have higher deficits under to the greenhouse. Okay, but all of these go in the same line. No? Here we have deep raining and all values go up. Okay, the second part was correlate. We did a model to correlate the values of the stem water potential, the only stem water potential with other factors. We can select that the temperature is in Fahrenheit and solar radiations and humidity and important factors to modelize the values of the water potential. We can see the R square is close to 0.8, and we can see when we have higher temperature and higher radiation, the values of the trunk water potential was lower. At the end, we have higher stress, and the opposite way is the humidity. These values was calculated only with 2021. It's the first trial, and with the data that both years we did other model. In this case, it's a super vector machine model. We calculate the value of the stem water potential every hour, and the R square is 0.67. Okay, the model used 1,600 values to training the model and 800 to validate this model. And here we introduced the temperature, humidity, radiation, and precipitation. Okay, the temperature, humidity, and radiation go in the same way that I talked in the last model, but here we can see that the precipitation, when we have low precipitation, we don't have variations in the values of the stem water potential and the trunk water potential. After 3 millimeters, when we have higher precipitation, the groundwater potential is lower, and when we arrive at 10 millimeters of the precipitation, the tree we cannot see any reductions of the values of the groundwater potential. I think that this is the maximum capacity that have the tree to suction water, and this is the lower value of the stress. Okay, but it's important to know this. And this we did this with all these parameters, but after we talked with people that worked with me, and we decide to introduce BPD and remove precipitation, humidity, and temperature and radiation. And we did two models. One is the multi-regression model, another is a super vector machine. Both models, the R square is similar, is 0.77, 0.78. And both models, we introduce the same values, is 3,800 parameters to modelize. Okay, the objective is we want to know in what moment we'll have a stress before to have a stress to turn on the irrigation before that the trees have stress. Okay, but we can see that the BPD and the solar radiation, when higher values we have in these both parameters, the trees have higher stress, and at the end, it's the normal. Okay, this is the hourly stem water groundwater potential. Okay, this is 12 a.m. 2 p.m. It's a midday. We can see that during the night we have lower values. The groundwater potential, we have lower stress, and in midday, in all treatments we have higher stress between 2 and 3 p.m. in New York State. Okay, but it's important that remember this value of the minimum and this graphic, because after I will talk other time about this. Okay, the fruit growth model. The fruit growth we evaluate by caliper. We put signals in the fruit. We measure the fruit size every week in the same point, and after we use the dendrometers during all season. To know what is the shrinking and swelling in the fruits during all season. We use the dendrometers. We net is an Italy company. We have problems because this point here it's very small, and the dendrometers was falling all time. When the sprayers go for the plot, the spray here and the windy periods we fall. We need go every day to the field to put these dendrometers and have good data. However, we have 24 dendrometers for each treatment. At the end, we have close to 60 dendrometers in all experiments to evaluate shrinking and swelling. Okay, this is the fruit growth rate. During all season in 2022, we can see that we have higher fruit growth rate in the beginning of the season in June and July. During this period is the period that the cell division and cell expansion. And after in September, the fruit growth rate is lower. At the end is the time that the apples win color. But we can see here that usually it's more important the irrigation during this period that we have higher fruit growth rates, and we have the cell expansion period. And the second part is the shrinking and swelling average during all season in July, August, and September for all treatments in the season 2022. And we can see that we have higher shrinking and swelling in July. And then here we can see that we have a negative values or higher negative values in the water deficit treatment is the red line. The all other treatments was close to zero, and the fruit growth more during the night. In August, we can see the same pattern, but we don't have negative values in this case, but we can see that higher growth during the night, and after here, lower growth during midday. And in September is the period that we win color, the fruit growth is lower, and we don't have difference during all day. Usually the temperatures in this timing, it's very light in New York. In 2023, we have the same parameters. We start in June, July, August, and September, and we can see the same that I show before. I don't know what is this square, but we can see higher negative growth in June, in July, but in August and September, the shrinking and swelling was lower. But the night time is the most important during June and July for have higher fruit size. Okay, for this, we correlate the values of the strong water potential with fruit growth every hour during all day. Okay, we can see here, this is the values of the dendrometer, the shrinking and swelling. And here is the values of the stem water potential, strong water potential in all treatments during July. But you can see that both parameters go in the same way. The minimum is at midday and the higher values it's during the night. This is July, this is August, it's the same. And for this, we did a logistic model to correlate the values of the fruit weight. In this case, we evaluate the fruit weight every hour, okay, the evolution of the fruit weight and the values of the strong water potential. Okay, this is in all treatments, we can see that we have negative growth after 10 bars after 10 bars. No, the strong water potential. For this reason, we estimate, or we can say that in New York we have higher stress after this value of the strong water potential, and we estimate the range that medium stress between 8 and 10 bars. Okay, but here after 10 bars we have higher stress and negative growth. We used these values to manage the irrigation in New York State in 2023. Okay, this is the result of the yield parameters. We don't have difference in terms of the fruit numbers per tree. We have a difference in yield. Okay, we have higher yield in fully irrigated trees, but the number of fruit is the same. This is because the fruit weight is higher in the fully irrigated trees, followed the only irrigated by rain, and the lower fruit size for rain exclusion treatment. Okay, we can see that here we have a high difference in the color. We have this difference because under to plastic, there are different light interception, or the light is different inside to the plastic. At the end, this penalized to the color, and the temperature will be a little bit higher under to the plastic. In the economic analysis that we did, this is the real data with yield. Here, I said that we have difference in terms of color, and the colors influence to the yield, to the profit, to the crop. For this reason, we introduce the same color in all parameters for see what is the effect of the fruit size. And we can see that we have higher profit in the fully irrigated trees. It's $42,000 per hectare. Follow it. The rain is $24,000. At the end, we have only $7,000 the profit in the rain exclusion treatment because the fruit size was lower and the profit it's lower. Okay, we go in 2023. Is this last season? I put this graph because it's the graph of the precipitation and that we can see in the world. We can see that New York is here in the circle, and if we go here, we are in the same area that the north of Spain and middle of Italy, but here we have more influence to the big lakes, and the precipitation is higher compared with Spain or Italy. Or if we go more to the north in France, the precipitation is lower. Okay, we have lower extreme weather conditions in New York. For this, we did 3 experiments in all areas, in all apple areas in New York State. This is Buffalo, is the first area that we put this experiment. The second area is in Hudson Valley, in other is in Champlain Valley. In this case, we have only 2 treatments. One is fully irrigated, was irrigated with drip irrigation and only rain. Another treatment is only irrigated by rain. We put sensors, floral poles, and we manage the irrigation in these areas with the value that I said before, when we have higher values than 10 bars, we turn on the irrigation. We didn't validate the models, but we manage the irrigation thinking that the stress value is the 10 bars in all three areas with the sensor flower poles. In Hudson Valley, we can see a little bit lower number of fruits in not irrigated treatment, but it's not significant. And we can see 10 grams of difference between treatments, but it's not significant. We don't have significant difference. This is the values of the sensor floral poles. This is the line of the 10 bars. Okay, we can see that here the grower, we don't say anything at this grower. And after we talk with the hey, we arrive at 10 bars, it's necessary to turn on the irrigation in this block. This is June, the all values. But after in July, you can see that we only have deficits in the Hudson Valley, in the not irrigated treatment, but the fully irrigated treatment, when we turn on the irrigation, we never arrive at values of the stress that I said before. Okay, here it's in August. We can see that here we have this flat line in the fully irrigated treatments. When I saw this, I thought, okay, the sensor is broke, but after I will show you the data, the all other areas, and you can see the same pattern. And the trees not irrigated need more time to have this flat line. Okay. This is Champlain Valley. Here they have a lot of raining. They don't have more problems. At the end, we have significant difference in the fruit size, and this difference is the same in the number of fruits per tree. And this is we can see the difference in the fruit size, but in this case was not significant difference. This was managed for the grower. They did hand thinning. At the end, we have difference because it's difficult to manage field trials with growers. But we can see that in June, we never arrive at 10 bars. In July is the same, but here we turn on the irrigation because when we see that we don't arrive, we won't see difference and we decide to turn on the irrigation sometimes during the season. Here we don't arrive at 10 bars, and we again here we can see the flat line in the fully irrigated trees before not irrigated trees. Okay. In Buffalo, we don't have difference in terms of yield. We have a lot of raining. Again, we don't arrive at 10 bars. Here is the same. Here we have a small day that we arrive in not irrigated trees. But here again, we have this flat line in not irrigated trees. Okay, we have a theory about this. We think that the trees accumulate reserve before if they feel good, or they have better accumulation of the reserve when they are fully irrigated and they don't have any stress compared with not irrigated trees. But we will validate the result the next season. And the conclusion, the floral poles successfully monitored the groundwater potential continuously in apple orchards. Radiation, humidity, rainfall, and temperature was important to manage the irrigation and was correlated with groundwater potential. And it's possible to manage the irrigation with the floral pole sensor. I want to say thank you and all people that collaborate with me during all these experiments in this last 3 seasons. Thank you, and all of you. And this is all. Thank you very much for your attention. Let's go.
Thank you very much, Luis, for the presentation. Thank you. I think we can proceed with the next speaker, and then at the end we have for sure some time for discussion. So please, Victor, the floor is now yours. Thank you. We can see your screen, Victor, but the microphone is off.
And now?
Thank you. Yes, great.
Thank you, perfect. Well, thank you, Ricardo, for your kind introduction. I'm Victor Blanco, and I would like to talk today about the physiological growth and yield responses of pear trees to different irrigation regimes. This work was done while I was a postdoctoral researcher at Washington State University in Lee Kalsik's lab at Washington State. Well, as Luis has said, and that's what it is about, FruitCREWS is about trying to manage irrigation and trying to adapt those new conditions that climate change is arriving to the way that we are producing fruit. If we check here this map, which is similar to the one that Luis saw before about the rainfall patterns, we can see that those temperate areas that are here in red are areas that are highly vulnerable. And that's going to have impact on the way that we are cultivating, for example, pears, because those areas here that we can see that are red, as the Mediterranean region, but also South Africa, Chile, Australia, and also the United States, are the areas where pears are produced. So pears, as many other fruits, needs to adapt to the new conditions and need to be more resilient to climate change. In this case, I'm going to talk about the production in the United States, and there are 17,000 hectares of pear orchards in the States, and most of them, the 83%, are located in the Pacific Northwest. The Pacific Northwest is located in the area of Oregon, Washington, and North California. The mainly production there for pears is for fresh fruit, so it's pear that are going to be eaters, and the general production, the cultivars that we work with, is mainly anjou pears, which is 50% of the total production of pears. To have an idea what I am talking about, is this winter pear, is kind of a round-shaped pear, and the problems that growers have when they are cultivating the anjou pears are related first with vulnerability to droughts and climate change, but also to the excessive vigor of the pears in general, and then you in particular. And this is related with pear psylla, which is a big problem there. And in over-irrigated trees, the impact of the pear psylla is much bigger, because the psylla is going to stack the sap of the tree and is going to produce a honeydew excrement, which is going to affect the appearance of the pear. And at some point, those pears can be sold. So the production is reduced, and they are going to have like a lot of economical problems because they are not going to be able to sell those pears. So in order to kind of think about strategies that can increase water use efficiency and also reduce excessive vigor of the trees, we were going to apply regulated deficit irrigation with that objective of assessing how to irrigate, how to manage irrigation to produce high fruit quality. In order to decide when to apply the deficit irrigation in pear trees, in Washington, winter and springtime is pretty wet, but it's impossible to apply water deficit there for growers. And also, we didn't want to apply deficit in any stage in which we can affect the cell division of the fruit. So the deficit irrigation was going to be applied in the stage of fruit development, which is the summertime, the moment when water is needed. So the objective of this work is going to be study the effect of regulated deficit irrigation strategies on the water status, yield, and vegetative growth of adult anjou pears in order to optimize irrigation water management and improve high quality fruit yield. With this objective, we wanted to decrease, as I said, the vegetative growth, but we don't want to strongly reduce the size of the pears, because that's also a main motor to get high values, high prices. So the experiment, or the results that I'm gonna show, they are from an experiment which took place in central Washington under a semi-arid climate. These results were taken in 2022. This is the second year of the experiment. The trees were anjou pears grafted on OHF 87, and the density of the trees was similar to 833 trees per hectare. The irrigation was with a drip line, one line with 5 emitters per tree, and we considered soil and plant water status, the vegetative growth, and the fruit growth in order to assess how the effects of the deficit irrigation has on the vegetative growth, but also the production of the trees. The two treatments that we impose was a control treatment, which is going to be always in blue, and a deficit irrigation treatment in red. The control treatment was irrigated to satisfy tree crop needs during the whole season, and the deficit irrigated treatment was irrigated to satisfy tree water needs during the first part of spring. And after that, during the fruit development in early July, late June, we are going to decrease the water that we are applying until a 50% of the tree water needs, with the idea of reduce the excessive current season shoots that the pear trees can have. We have 3 reps per treatment and 6 trees per rep in a completely randomized block design. The environmental conditions in Washington during 2022 were clearly different during the season. So for the first part, spring, the VPD values were lower than 2 or close to 2, and the temperature was similar to 2025, the maximum temperature of the day, 25 degrees. But during early August, late July, we have a heat wave, and the temperature was higher than 40 degrees Celsius, and the reference evapotranspiration was also pretty high, with values higher than 8 millimeters per day. So these conditions had an impact on the way that we were assessing the treatments. But when we compare the soil water availability, as we always irrigated, based on the environmental conditions, try to have a stable soil water availability for the control tree in blue. But for the DA treatment, the water availability decreased from the moment that we imposed the deficit irrigation. As a general value, we apply 5,000 cubic meters per hectare to the control trees, while for the DI trees, we applied 3,250 cubic meters per hectare. In order to assess the physiological response of the trees, we measure the trunk water potential with the microtensiometers, which, as Luis explained previously, is a new sensor that can directly measure the silent pressure of the tree, and it is inserted in the trunk of the tree. And this microelectrical pressure sensor is going to provide us with a value of the trunk water potential, which is the new indicator that can be compared with the stem water potential measured with the traditional Solander pressure chamber. Here we have in the right part of the slide the daily evolution of both indicators, and we can see that while for the pressure chamber we were measuring every 2 hours and we have the same evolution, for the microtensiometers we can have a value every 20 minutes. And the pattern of both indicators is the same. So for these values, this experiment was did in 2021, the year previously to the results that I'm going to show right now. We can see that there is a strong relationship between both indicators, the trunk and the stem water potential. So our idea was to follow not just the daily evolution, but the seasonal evolution. Here we have the evolution of the trunk water potential measured with the microtensiometers during 2022, and how before the irrigation change, which is the vertical black line, the values for both trees were pretty similar. However, once the deficit irrigation applied, and especially in green, we have the values of the heat wave event, we have really different values for each treatment. While the pre-dawn values for the pear trees irrigated as controls were similar to minus 0.2 megapascals, for the D8 trees was minus 0.5. And the minimum values of the day were minus 1.5 and minus 2.5. Minus 2.5 megapascal is a value that it is really negative, which means that the trees that were the deficit irrigated were under severe water stress, at least during those days in which the heat wave took place. We compare now the values measured of the midday, because the midday stem water potential can be used in pear trees as a reference tree water status indicator. We can see how the values are not as negative, but it also has an impact in the midday stem water potential with values for the control trees of minus 1 megapascals and minus 1.6 megapascals for the DI trees. This difference is because the value which is measured during the midday, it was not the most negative value of the day for the trunk water potential. However, both indicators were clearly able to identify the water stress applied to the DI trees and were able to recognize the tree water status. So the deficit irrigation has an impact on the physiological response of the tree measured as both midday trunk water potential and midday stem water potential. Related with the relationship about both indicators, we can have here the now with much more values because it's a seasonal value of the midday. From minus 0.5, we can be a condition of a controlled tree or trees that are irrigated to satisfy their needs or under no water stress until values of minus 1.6 megapascals, which can be value recorded in trees that are irrigated only to help them to produce fruit, but not to satisfy their needs. So a mild to severe water stress. Both indicators were pretty close and have a value that can be represented with a one-to-one line. So the relationship was really good between both indicators. Moreover, we wanted also to compare not only the trunk and stem water potential, but the diameter or the changes in the diameter of the trunk and the diameter of the fruit in order to have a real value of the energetic state of the plant with the water potential, but also the growth, the physical growth and the vegetative growth of the trees with the trunk dendrometers and the growth of the fruit dendrometers to compare if the irrigation and the strategies that we were applying had an impact on the vegetative growth and the fruit growth. So in order to measure these values, we consider the maximum daily shrinkage, which is the difference between the maximum and the minimum value of the trunk diameter every day. So the bigger the maximum daily shrinkage means that the tree is more stressed, so it needs the water which is within the trunk to transpire. And also we measure the trunk growth rate, which also can be considered the fruit growth rate. And it's the difference between the maximum daily diameter of the trunk or the fruit in 2 consecutive days. So if the maximum daily diameter is growing during the season, it means that the fruit has water and can potentially grow according to the different conditions or environmental conditions in which the tree is. So here we have the evolution of the trunk diameter fluctuations during the season. And again, the behavior of the trees was really similar while they were equally irrigated. But once the deficit irrigation was imposed, and again, particularly during late July, early August, when the environmental conditions were very demanding with VPD values that were similar to 4 or 5 kilopascals and temperature of 40 degrees, we can see how different, while for the control trees, they go on growing. For the DI trees, the maximum values was really similar during those days, so the growth was much smaller. At the end of the season, while for the control trees, the values of growth were similar to 1,700 micrometers, for the control trees, the values were much smaller, similar to 900 micrometers. So the trunk growth rate result is affected by the irrigation strategies that we apply. We measure not only the evolution, but the maximum daily shrinkage, which is the difference between the maximum and the minimum value recorded each day. We can see that there were differences between treatments, and the DI trees have a 30 or have by mean 33% higher values of maximum daily shrinkage compared to the control trees, which also had high values during those days in which there was highly demand, values that were close to 200 micrometers, but they were always much smaller than those of DI trees. So even though we weren't able to have a threshold value to identify when the trees were stressed, when we compare both treatments, consistently, DI trees have much more bigger or greater values than control trees. When we compare not only the maximum daily shrinkage among treatments, but also with the midday trunk water potential, we observed that there was a relationship between them, and as expected, the more negative the trunk water potential, the bigger the maximum daily shrinkage. But this pattern was not followed during the whole season, as we observed that for values of minus 1.3 megapascals or below, the maximum daily shrinkage was not increasing as much. So with values close to 200 micrometers, that can be indicator value of water stress, or that the conditions are highly demanding for the pear trees. About the vegetative growth, I have here two pictures, just in order to have an idea of how different the trees were and how much a pear tree can grow if you apply water to satisfy their needs. And here for the trees, I think that you can easily see how much leaf area and current seasons you have. But if we see the picture of the trees while we were pruning, there is much more obvious the difference of the excessive vegetative growth of the pear that were irrigated as control. So when we compare the pruning booth, we have more than twice the kilograms of booth for the control trees compared to the DA trees. And this booth was mainly related with current season shoots, which has a great impact on the leaf area too. If we were able to limit this new growth, we can decrease also the vulnerability of the pear trees to the psylla, as the psylla always prefer this new tissue and it's going to stack. So if we reduce these current season shoots, that's the aim of the study, we also decrease the vulnerability of the pear psylla to affect these pear trees. We compare now not only the vegetative growth, but the fruit growth. Here we have 3 moments during the season. The first one, the 24th of June, for both treatments is when they were equally irrigated. So we see how much they grow with values that, as Luis explained, with the apple, they are much greater than later in the season. However, once we apply the deficit irrigation, we observed that those days in which the evaporative demand was really high, the values even for the controlled trees were much more smaller. So the difference between the conditions for the fruit growth was much more related with the water availability in the soil when the environmental conditions were not that much demanding. At the bottom of the slide, we can see the differences in the fruit diameter during the whole season and how different at the end of the season both fruits were. While one had values closer to 65, 70 millimeters of diameter for the control trees, the trend is like a straight line in which we can see that values are close to 70 or 80 millimeters of diameter. When we compare not the whole season, but only those values of the pears while they were with high soil water availability, so early in the season, or for the controlled trees during the whole season, we can see that when the values of the VPD were higher of 4 or 5, the fruit growth rate was close to 0, which means that the environmental condition has a huge impact on the way that we are growing. So climate change can be a problem if we don't adapt to those conditions. But if we check for the conditions of the whole season, so when the midday trunk water potential was really low, we can see how for the trees that were, for the DA trees, the trees that were under water restrictions, the values are much smaller as the trees are more stressed, as we expect. However, if we move in a threshold value of minus 0.6, minus 1.2 megapascals, which can be pretty standard in an orchard during the summer, we can say that 33% of the pear growth can be reduced if we are much more closer to those values of minus 1.2 than to those of minus 0.6. So we can give a number of the impact of if we talk about the trunk water potential compared to the fruit growth rate. when we assess the yield and the fruit quality of the pears, we can see that the yield was similar between treatments, but when we compare the total number of fruit, it was much bigger for the VA3, which has an impact on also on the deficit irrigation that we were applying the previous seasons. So for those trees that were deficit irrigated, the amount of fruits was bigger. Also, the number of not just total, but the fruits fallen was bigger for the DA trees, and the fruit firmness was lower, which indicated that the trees were ripened earlier than the control trees. So in the moment that we did the harvest, the pears that were deficit irrigated were sweeter, but they were not as hard as those pears that were irrigated as control. The size of the tree was, the size of the pears was also much more smaller for the DI trees compared to the controls. And if we talk about the impact of the number of trees that have any symptom of Persilla, for the DI trees, Persilla affected less than 3% of the total fruits, but for the control trees, the number of fruit affected ranged between 0 but also 12% of the production. So to sum up, as conclusion, we can say that all the indicators that we assess, the stem water potential, the trunk water potential, and the maximum daily shrinkage, were able to detect the water stress that we apply, and were able to identify that we were applying a severe water stress. Based on those results, the trunk water potential was stable during the season and was much more, or didn't show any drawback compared to the maximum daily shrinkage, which has a maximum detection value of minus 1.3 megapascals. And we are able to continuously measure the tree water status with this indicator. And the results regarding the agronomic response is that the vegetative growth was much more sensitive to water deficit than yield. So applying not as a severe water stress as we did, but a slight water stress can have a good impact on your trees. And also that preventing having or over irrigating your trees and having vigorous trees is going to have a good impact on the way that you are spraying your trees, as the penetration of the product into the canopy is going to be much better. Water savings of 1,800 cubic meters per hectare, which is a 35% of the water that a control tree needs. That's not going to penalize the number of fruit per tree. However, it's going to have an impact on the size of the fruit. So that's going to produce a proportion of a smaller fruit much bigger than those control trees. And thank you so much for your attention.
Thank you, Victor, also for this great presentation. And I think now it's open the session for the discussion, if someone has some question. I have actually, oh, there's a hand from, yes, please, Virginia.
Hi, my question is for Luis. You said that you couldn't keep in place the fruit sensors and you have to fix them every day. Is that right?
Yes, yes. Practically every day. Sometimes every 2 days, all depending the sprayers and the weather conditions. If we don't have windy days and all these extreme situations, usually for 1 or 2 sensors, I didn't go to the field. But when we have a lot of sensors, yes, I went.
Because we had kind of the same problem with lemons, and I asked Brunella, and she told me that somehow you can fix them in the same branch where the fruit was growing, and somehow we managed to keep them in place.
Well, yeah.
I mean, not always. It's true that I felt like really identified with you because in the beginning we had the same problem.
Sometimes I try to find fruits in flat structures that it's close to the trunk, and these have lower movement, but I cannot select all in the same fruit in
Yeah,
the
yeah.
same darts because I need to have this variability that there are between fruits and different structures. But yeah, it's a little bit stressful.
Yeah, yeah. I
Oh,
agree.
Thank you.
Yes, please. Carlos Lopez, the question from the public.
Hello, everybody. So I just want to know the feedback from both speakers, because both of you have used the FruitCREWS tensiometers. And what I want to know is, what is your opinion regarding the potential use of those sensors for many years? Do you need to remove them during winter, or can we use them for several years without removing? What is your opinion?
You have to, or at least based on my experience, you have to reinstall them early in the season. So you can't leave them the whole season, at least based on the conditions in which I was working. If you wanna have like measurements that are robust, you need to reinstall the sensor early in the season. And even if the conditions are really cold during the winter, it's much better to take out the sensor during the winter, leave it in the lab, and then reinstall the sensor, because if it is pretty sensitive to values that can go of temperature below 0. So if you, I don't know, but depending on the environmental conditions, it's much better to always reinstall.
Okay, thank you.
Oh, I don't know, Luis.
Luis, do you have another opinion?
But it's similar. I used it during 3 years, the same sensors. I can see that we lost sensors continuously. Okay, we start with 12, and after 2 seasons, 5 was broke. We need to buy new sensors. Usually when we remove to the trunk, it's a little bit complicated. Okay. I know that persons use it during 2 years, but usually this year the values here, and after, okay, there are a cicatrization inside to the, and after the values go down. There are cases that it's not, but in apples, yes. And yeah, I say the same that Victor, it's necessary to remove and recalibrate every season. There are a process for calibrate the sensor. One is you can put in DA water this sensor and see that the zero is close to zero, the value is close to 0. After, other thing is remove the sensor outside to the water, and you need to see a reaction, but not more time. You put outside. There are instructions of the FruitCREWS company for to do all of these steps. But it's another thing. Sometimes there are more variability between values in different sensors. Okay, so you can see that all graphs go in the same way, and one sensor is here. It's necessary to check with pressure bomb if this value is correct or not. If it's not correct, you can do 2 things: to do a coefficient factor to adjust this value in the same line that the other sensors, or don't use this data. In my case, I didn't use it. I don't.
Or reinstall. You can also reinstall the sensor just in case that maybe the values were not as good. So even if during the season you see any problem, maybe you can try to reinstall it. Maybe there is a problem with any air bubble, or there is not a good contact between the xylem and the sensor. So yeah, it's much better. And also the pressure chamber is going to be like the key factor here. If the values are really close to the pressure chamber, yeah, the sensor is working. If not, I would always recommend to reinstall, because it's much safer.
Okay, thank you very much.
Okay, so do you have other questions from the public? Otherwise, I have back couple of questions. Maybe the first for Victor. I found, and then Rafael, maybe you can go first.
Yes, my question is for Victor, and it is mainly like related to the pruning. What is like in pear? What is your experience like? Is the deficit irrigation too much? Like, was it too severe? And in the long term, could it affect the structure of the tree?
Well, it was too severe. We have more treatments, and this one was pretty severe. We have even one treatment which was, or we have some trees that were under much more severe water deficit, and that obviously can have a really bad impact. In our case, it was not that much related with the pruning, which decreased, and it was a good result, but with the size of the fruit obviously drastically decreased. And generally in pears, the money is not that high, the revenue of the growers. So having a big or a significant higher proportion of a small fruit, yeah, makes that treatment is not that interesting for them.
Thank you.
I also have a question for Victor. So you said that the yield parameters were not much affected for associated with the deficit irrigation, and you have more beneficial effects for controlling the vigor and the psylla, basically. So is deficit irrigation based in the area in which you were operating and the variety cultivated agronomical practice that is currently used, or is more on the experimental side, let's say?
It is much more, yeah, in the experimental side. In fact, the problem there is they over-irrigate.
They over-irrigate, okay.
Yeah, like water there is not that expensive, and it's not a problem. So in order to avoid having small fruit, because they are scared of having a big proportion of a small fruit, they irrigate that much that they have problems with fruit quality just because of the sun exposition of the fruit, or like sometimes even the fruit can be that big that they can have problems with the nutrient profile. So generally the problem is that they over irrigate the fruit much more than any other irrigation management.
Based on the results that you showed, these are quite maybe encouraging in this way. So maybe a slight less deficit, but would you suggest this kind of operation, I guess?
Yeah, especially in those orchards that they have huge problems with psylla or with fruit that has problems of light penetration, I would recommend any kind of control of the irrigation based on the tree water status, as maybe something similar also, like having a threshold value in which you can irrigate depending on those conditions, but avoiding over irrigating the trees as a general irrigation strategy.
Okay, thank you. We have a question from the public, Alon.
Yes, I guess it's mostly for Victor, but maybe also for Luis. I'm very impressed and it's very optimistic, the results from the FruitCREWS sensors. I'm a little concerned about not being able to find a threshold value. How would you suggest using these sensors to guide irrigation if we can't find thresholds because they're so sensitive to the environment?
Sorry, are we talking about like a threshold for a specific cultivar, or a threshold in which the sensor is working?
No, a threshold for specifically guiding irrigation. So specific cultivar during the season, but being able to see the numbers and knowing when you need to irrigate.
No, I just wanna say that the way in which we are measuring the continuous tree water status, like by measuring how the energetic state of the subflow, the xylem. That's an improve in the way that we are considering, but it's not the only way, or it's not the best way. Obviously, we should go on working, and we should compare, look for which combination of sensor has a great impact. Just compare with other continuous measurements, as for example the dendrometry. I can see that it's much better to have a threshold value if that threshold value is related with the megapascals of the energetic state, like the water status of the tree, than a maximum daily shrinkage. So if we compare the ability of the microtensiometer with other sensors that can provide a general idea, I would say that to me, it's easier to follow a megapascal scale than micros, or I don't know, like a maximum daily shrinkage value. But it is not that it is going to be a unique value of threshold. So I don't feel that that's the point of the sensor, or at least not the point of the experiments that we have.
Yeah. Thank you. That's a very good answer. Luis, you did find and use threshold values, right?
Repeat, please. Can you repeat, please?
For apples, you succeeded to find a threshold value that seemed to work, right? At -8 or -10.
Yeah. But obviously in New York is different because we have a lot of rain, and the root surface, they don't have this bulb or this area that it's although they don't have deficit usually. And I think that my values, it's fine for New York, but obviously I see the Victor values in pear. They arrive at -15 bars.
Yeah.
In the fully irrigated treatment, it's different. Yeah. But yeah, for apples in New York, yeah, we will try this season here in Spain conditions, and we will see if it works the same.
Thank you.
Okay, another question from Rafael, please.
Yeah, my next question is more related to the question from Alan. Is that if there is a threshold for the functioning of the sensors? Because like I'm here in Seville now, and we have like too much drought situation, so there is no rainfall during summer, for example. Is there a minimum threshold? And like, for example, farmers have less and less water available for the irrigation. So is there a way to use, maybe it's two questions. Is there a threshold for the functioning of the sensor, or does it disconnect from the hydraulics of the plants? And the second one is it possible to use fluoropost to at least not kill the plants by drought?
There is a problem that you can have cavitation, so obviously that's gonna leave the sensor not or destroyed. Yeah, so I would say that you should be aware of that you can go lower than, I don't exactly, or I don't want to say a value that maybe is gonna have any problem, but I guess that if you always are gonna be in a safe area, if you move till -2.8, -3, I think that even it's pretty negative, at least for apples, for pears. I know that for other crops can be a regular value in some conditions. But yeah, there is a mechanical value in which the sensor is gonna be broken. So if cavitation happens, that's not gonna let you go on with the measurements, even if the value is just recorded for once.
Yeah, I think the same of Victor. In one meeting, maybe 3 weeks ago, they talk about this, and there are a limit of bars. I didn't remember what value they say. It was -10 or -40 bars, but there are a limitation.
Yeah, also maybe in pots, in experiments with pots, not soil, that can be a big problem, because maybe those values can be measured pretty fast, just because of the soil volume is so small that maybe that can be a limitation for those small trees.
Thank you.
Any other comments or questions from the public? So just a general question, do you have experience with the soil moisture sensor or point scale, let's say, to compare with more microtensiometer, for example, that you are more used to use for also comparing the soil water characteristics other than plants?
I don't have experience, but here in they have a 200 orchards with soil sensors. They have a 20, 40, and 60 centimeters the profundity, and the objective of this year is put the floral sensors the same place that we have these soil sensors, and see what is the, well, correlate these values, but I don't have experience before about this.
Yeah, well, soil sensors are maybe the sensors that are most commonly used by growers nowadays. So it is always good to consider them in order to be able to compare these new sensors that can be used by researchers with those that are considered by growers. So it's always good to, if we want to implement those techniques, to consider also those sensors or that technology that is commonly, or you can easily find in commercial orchards. As a comment.
Thank you. Yeah. Well, it was just a general consideration. Thank you, both of you. So you're now operating in Spain. I guess you are expecting some different season, I guess, during summer. Are they using for maybe different reason deficit irrigation in the area of Spain you are working? Or I don't know, deficit irrigation, as you explained in US, can be used for manage the vigor of the variety of pear, but maybe in other areas they can use in principle to save water. Are they using such operation?
Well, yes, because we are now under a major drought. So yeah, any strategy, anything that can help to increase water use efficiency and to try to use as less water, or try to use the water with the highest productivity as possible, can help growers fruit growers particularly, because they have like woody perennial trees. So in all the water savings in all Catalonia are really important, but particularly also in Girona, where Luis is, the situation is really bad.
Yeah, we will see if we could irrigate the trees this year. I don't know. We don't have. Maybe we can do survival irrigation, but I don't know exactly. For now, we have rainy, but we don't have reserve of water for irrigate all season, and we will see what we do this year. It's very critical. In Lleida, they have a little bit more, no? Maybe for save this season, But
Still, yeah. Well, last season was bad, and the predictions of this season is that it's going to be bad too. So any strategy, all the research that is done to try to help growers and try to maintain the production, and obviously to try the trees to keep them alive is
It would not be
needed.
bad.
Yeah,
well,
would be appreciated. Yeah.
the first step is lower crop load. After, if this is not sufficient, it's lower canopy. Do very pruning, but not more hard because we need fruit the next season. Well, it's we will see what we do this year, but it's very different. We are.
Thank you. So we have a question in the chat from Hendrik Kulaj. For Luis Gonzalez, can the modules used by you be used with the subflow data? And a few comments on the models.
Well, the models obviously is for predict the values of the stem or the trunk water potential. It's not. I don't use it. The subflow. If we have this continuously measuring, could be easy to correlate all of this. But in my opinion, for me, it's very important. These sensors, we use a lot. These sensors for have a lot of data and predict these values before have stress, because it's easy to have forecast or predictions the we other parameters, and if we can modelize with we other parameters, this maybe with 2 or 3 sensors per block or 1 sensor, and to validate if the predictions go in the same way that we have, could be cheaper for the growers, because for now it's very complicated. Use this sensor for the price, basically. And obviously, I think that it's better use with other parameters that it's easy to find in public weather stations that I showed before. For example, radiation, rainfall, humidity. That use other that needs to do calculations. Yes. That is this. I think that I answer.
Yeah, thank you, Luis. Yeah, all quite clear. Okay, there's any other comments or questions from the public? Okay, apparently not. So I think we are coming to the end also from this session, the March session of FruitCREWS e-seminar. I'd like to thank you all for being present in this March seminar, and also thank you for our presenters of today, Dr. Luis Gonzalez and Dr. Victor Blanco. And I'll give you an appointment for the next e-seminar, which is not yet fixed, but any news will be communicated as soon as possible to you. And hopefully we will see you soon for the other seminar. Okay.
Thank you, Ricardo. Also.
Thank you all. Thank you, Brunella. Thank you again, Luis and Victor. And have a good afternoon or evening or morning, depending where you are located now.
Thank you. Have a nice day.
Thank you.
Okay.
Bye.
Bye. Thank you.
Bye.
Bye. Thank you for the presentation.